Hello, professors. Thank you for watching our research project presentation. Our group members are Yihao Chen, Jinghan Wang, and Junzhou Zhang. The topic of our report is machine learning-based prototype for medical outcome prediction. I'm going to introduce the background, objectives, and dataset of this project. Machine learning allows building models to quickly analyze data and deliver results. Use machine learning, it is possible to make better decisions about patients' diagnosis and treatment choices, leading to improved medical services. The project objective can be divided into 4 parts. The first part is data navigating. This part is searching and collecting information. We connect the contents of 3 tables based on the subject ID to create a new data table for modeling. The second part is data modeling. After data processing, it is possible to predict the mortality rate and the possibility discharge under 24 hours of the target patient. The third part is data visualization. Use a pie chart to show the ratio of male to female, and bar chart were used to represent the distribution of the number of admissions. The fourth part is GUI design. In order to create a prototype or an application that can interact and demonstrate the above functions, a GUI is designed and implemented. The goal for the GUI design is to achieve user-friendly, high interactive efficiency and can be concise. This project mainly uses 3 datasets. They are admissions, patients, and diagnosis ICD. The admission table has much content, including admission and discharge time, death time, the patient's demographic information, and the classification of the urgency of admission. The patient's table has the information consistent for the lifetime of a patient, and the diagnosis ICD table contains records of all diagnoses made during the patient's stay in the hospital. For the prototype, we made 3 functional designs. The first is create a retrievable database by connecting the admission, diagnosis, and the patient tables. The second is several methodologies of data analytics are being investigated and assigned. As a result, 3 prediction models have been created and results have been analyzed. Thirdly, data visualization of predicting medical data is also being implemented. Bar charts and pie charts are applied to show the data features to make it more intuitive. Furthermore, the graphic user interface is to make the prototype a real application.
Okay, thanks Jinzhou presentation. Let's talk about our predictive model. According to the previous section, the dataset and object has been introduced. Let's move on to the part of modeling. The first, I will describe the process of modeling. The modeling consists of 2 main parts. The first part is the data preprocessing, which aims to transform data into a format that will facilitate the use of machine learning. Then the second part uses the algorithm commonly used in data analysis to process the data and obtain the prediction results. Finally, the results are analyzed to evaluate the performance of the model. Okay, let's start with the section on data preprocessing. This part also consists of 2 parts, data extraction and processing. As the original dataset is too large, with over 100,000 items, it is obviously not appropriate to extract data to train the model. So we decided to extract only 3,000 data as our training data. But there is a problem. How to select this 3,000 data? It is certainly not reasonable to extract them randomly. Since our first object was to predict the mortality, we decided to first calculate what proportion of the original dataset was there, And then from the graphs on the right, we can see that the dead sample represents 1.7% of the total data. So the method we choose to make the proportion of that sample in 3000 training sample the same as the original proportion is 1.7%. So we can see that out of 3000 samples, the positive data is 52 and the negative data is 2947. The next step is to introduce the data processing. As mentioned before, the purpose of data processing is to transform data into a data type that is convenient for direct use in machine learning. According to the machine learning, the most suitable data type is numeric, based on the data present earlier. Most of data is a categorical data and is represented as a task. This type of data is not suitable for machine learning, so one-hot encoding is used for data processing. The function of one-hot encoding is to convert categorical data into a numerical data in a binary format. For example, according to the admission type data we mentioned earlier, which contain 9 attributes, and after processing with one-hot encoding, as you can see from the figure on the right, each type of data is converted into a binary format. The processed data is then input into the model, and algorithm is applied to process the data to obtain the prediction result. The algorithm we use here is the decision tree. This is one of the common algorithms used in prediction model. So a basic prediction model is created. So let's look at the prediction result. In machine learning, performance measurement is an essential task. So we analyze it in two aspects. The first, we plot a ROC curve to calculate the AUC value of the model. We can see the curve and AUC value for both prediction in the figure on the right. On the other hand, the runtime of the model is also an important factor in measuring the performance of the model. As we can see from the figure on the right, that model talks about 1 hour to run for 3000 data. According to the result, the model is not perfect. Therefore, we need to optimize the performance of the model. There are two aspects. First, we need to consider how to reduce the running time of the model. As we mentioned before, the admission types are represented by 9 digits each after processing. But as one of our main data, the ICD code, there are approximately 3000 attributes for 3000 samples, and each code will be represented by 3000 digits after one-hot encoding process, which will obviously increase the runtime. So the top-level method is used to solve the problem of the long time. Before extracting the data, we calculate the 500 most frequent ICD code, and then only the data with these 500 attributes are retained in our dataset and extracted it according to the same rule. And then we also need to improve the AUC value of the model. There have two methods are used. The first one we call the balanced data. This approach is to make some improvement after the data has been extracted. As an example, after we have extracted 3000 samples, of which there are 52 dead samples, and then we replicate these 52 samples to bring them up to the same number as the negative samples. As shown on the right, they have 1,484 positive sample and 1,500 negative sample. This makes the sample reach a balanced state. On the other hand, the algorithm has a direct impact on the prediction result. Because the type of data is an essential factor that affects the performance of the algorithm, so we try to use two other algorithms for prediction, including the SVM and random forest. In terms of the result, it is clear that the improved model is very successful. Compared to the previous model, the running time is reduced up to 90%, and the prediction result is significantly enhanced, even up to 1 when applying the random forest algorithm. Okay, the modeling section has been presented. Let's move on to my teammate Yihao to introduce the next part. Thank you.
Hi guys, welcome to the demonstration part of our prototype design. So we will demonstrate and go through our design step by step. Okay. So this is the folder we used to store the prototype, and the file GUI will actually the enter of our application. So we will simply run the graphic user interface program. By execute this one, it will bring up the application page of our design. So if I run this, yep. So this is our login page. So we make minimum this, yeah. So this is the login page, and we can input our username. So it doesn't matter what I put here. So maybe just if we put nothing here, so it will just showing visitor. So this is the main page. Our design includes 3 main functionalities. So the first one, we can search for a patient's info. Second one, we build a modeling to give predictions. And the last one, we do the data visualization of our data set. So in the first functionality, we can search a certain patient by its patient ID. So I have already put 2 examples here. So maybe I will paste the first one. And copy the ID and paste here. And then we go submit, and it will bring up the page showing the basic information of this patient. And we can also view a detailed record of all its admission historical records by clicking the button here. I will carry for a second. Yeah, so we can have a full version of all the admission information of this specific patient. Yeah, and also because it's a female, so I put a female photo here. So if it's a male, for example, yeah, just showing all the functionalities of our program. So we'll have a photo like here as a male. So we can also do a detailed search on him. So this is the summary page. Yep, and the second one is the modeling. So we can give predictions to all the patients, and by building up modeling. So the first step of the modeling is you select the sample size and train test ratio. So we use drop-down menus here. So you can choose the sample size from 500 to 3000. Normally, a larger number will bring up a more accurate results. Yeah, so we will just use 500 here because we don't want too long for the program to execute. Yeah, so 0.3 is fine. Predict. And the second page will bring up the screen that you can select you can apply different filters to change algorithms or different methods on predicting data. So the first filter is asking if you want a data balancing or imbalancing data. So balanced data brings a good outcome, more accurate, but the imbalance it will not have a very good result. So we'll just balance data, and on the ICD method we mentioned in the report, we will use top 500 ICD. And the modeling approach, we will use random forest because it is the fastest algorithm among these 3. And we click next, and then it will bring up the result page so we can analysis what happened there. So after a few minutes, so we have the result of the analysis result. So as you can see here, the modeling time is around 30 seconds, and the AUC score for the first target predicting mortality is 100% accurate, and the second AUC score of predicting discharge possibility under 24 hours is 0.818, which is still very good. Yeah, so that's all for the modeling part. So if we go to the last functionality of our design, data visualization, so we categorize all the visualizations into either bar chart visualization or pie chart visualization. So let's start with the pie chart. So under pie chart, we have gender distribution, we have admission type distribution. So we will just quickly go through each visualization. So this is a gender distribution. So from this diagram, we can see female has slightly more than the number of males, and admission type distribution. So also a pie chart. It clearly gives us a very visualized result of, we can clearly tell which has the most number of admission type. So this is pretty clear. And if we go to the bar chart, so also we have two different things to visualize. So admission number distribution. So as in the bar chart, we can see that the most of people only attend to hospital for once. Yeah, this is what we can tell from the graph. And the other one is just another form of the pie chart. So we convert it to bar chart. So yeah, that's all for the visualization, and that's all for our demonstration of the prototype. So after the demonstration of the prototype, we come to the part that we analyze our results. So talking about analyzing the results, we mainly measure or evaluate the results in the term of modeling time, and the other factor is the predicting accuracy, or we can say AUC score. So in regard to the modeling time, the first comparison we would like to talk about is balancing data or imbalancing data. So in this respective, it doesn't really matter to the modeling time. And in regarding to the second measurement with comparison between top ICD with top ICD or without top ICD. So with 500 top ICD, it significantly reduced the modeling time, because we only analyzing data on the filtered top 500. So that significantly reduced the data frame, the size of data frame, so that it reduced the modeling time. And in regard of the three different modeling algorithms, so the random forest has the fastest modeling time among these three. And in other factor, we're going to evaluate it is the accuracy, or we can say AUC score. So balancing data and imbalancing data, balancing data significantly increase the accuracy or the AUC of the predicting results. And top 500 ICD also helps a lot, but not as important as the balancing data does. And in the three different modeling algorithms, decision tree has the worst results among these three, and the SVM and the random forest are all doing pretty well when giving almost 100% accuracy out of the two different predicting. That's all for the result analysis. And for the modeling algorithms, it is another conclusion of what I have mentioned on the previous slide. So this is an example of the ROC curves, the two different ROCs. This is using when we applying decision tree. And we also analyze the modeling time and accuracy, and then create a predict system results table. So we can see that balancing data and the top ICD, top 500 ICD, and also trying different modeling method can increase the predicting results all the way, and it goes all the way up. Yeah, and we finally use the balanced, and the top 500 gives the best results, and random forest gives an even better result among the other two different algorithms. So in conclusion, our prototype implement mainly three different functionalities. So the first one is the data ETL implementation. ETL stands for the extract, transform, and load of the data. And second, it implement the data modeling. So we mainly using one-hot encoding as our pre-processing data method, and we use top ICD filter to decrease the data size to have a better processing time, modeling time. And we also applied in total 3 different algorithms to test our result. And lastly, we did a data visualization to visualize all the data to make them very clear and easy to understand. And at last, in order to make it a prototype, or we can see application, we use the graphic. We create graphic user interface. We use drop-down menus. We use buttons. We use the switch between the different screens windows to make it fit into an application. So that's all for the presentation. Thank you.